Welcome back to the deep dive, where we cut through the information overload and give you the distilled knowledge you need.
And today, we are immersing ourselves in a really specific world.
We are. It's the extremely precise, often frustrating, but, ultimately rewarding world of expert fish keeping.
Yeah, and we're not talking about your grandfather's goldfish bowl here. These are highly structured environments.
Totally. Keepers are meticulously controlling temperature, chemistry, lighting.
And investing a huge amount of time and money just trying to coax these, complex behaviors out of their subjects.
Exactly. The stakes are just so high when you're dealing with specialized species. So for this deep dive, we're focused entirely on the actual granular notes from a keeper.
Someone who is tracking a very difficult breeding program.
Right, with 6 pairs of Zebra Cichlids. That's the Amygdalania nigrofasciata.
And the notes, they center on this one entry. It's titled simply, Our First Zebra Cichlid Spawn.
So the mission for us and for you is to solve a biological puzzle.
You've got 6 established, seemingly healthy pairs. They've all performed the right courtship and bonding rituals. But for 6 long weeks, nothing.
No fry, no eggs, 0 payoff. Then all of a sudden, one specific pair makes it happen.
So our job is to unpack those notes, to really identify the subtle, maybe even contradictory variables that separated that one successful pair from the other 5.
We're basically looking for a needle in a biological haystack.
And those initial conditions are so critical. I mean, if you're a dedicated keeper, you've done everything by the book.
Oh yeah, water parameters are optimized, diet's controlled, you've provided structures.
So when 6 weeks go by and all you're seeing are rituals, the posturing, cleaning, nesting sites, but no actual eggs, your first impulse is to just start changing everything.
Okay, so let's unpack this core dilemma then. The 6-week delay. If the water chemistry was, technically correct for all 6 pairs,
Yeah.
why the long wait?
Well, the keeper's notes start by tackling the simplest and honestly the most frustrating hypothesis.
Which is,
The variable of time. They note that the initial trigger, it's still elusive, but the data suggests these fish, they simply needed more time to acclimate.
to acclimate to the water parameters of a brand new setup.
Exactly. Even though those parameters were stable from day one.
That's so counterintuitive. I mean, most keepers would want to feel in control. They'd be hitting the tank with a huge water change or adjusting the hardness.
Or maybe dropping the temperature, trying to mimic a seasonal change to, shock them into spawning.
Right.
And what's fascinating here is that the keeper resisted all those immediate technical tweaks. The notes suggest that acclimatization in these complex fish isn't just about surviving the move.
It's something deeper.
It's about reaching a psychological or a hormonal state of absolute security in their new home. You can hit all the technical targets, the perfect temperature, the right water hardness.
But if the fish's internal clock hasn't accepted that this new setup is permanent, that biological switch for reproduction just stays off.
It remains dormant. So that acclimatization, it really acts as a prerequisite. It highlights patience and sort of biological comfort over just tweaking the numbers.
But hold on a minute. If they all performed the mating rituals, doesn't that suggest the hormonal switch was already, partially flipped?
That is a great question.
Why didn't those rituals lead to immediate results?
Look, the mating rituals show they're ready to bond, but that final high-stakes decision to lay eggs, which takes a massive amount of energy, that's likely tied to a much deeper environmental security signal.
So the rituals are almost like practice.
They could have been, yeah. But the final biological commitment, that only happens once they cross that security threshold of, okay, this is our permanent home.
Wow. That really frames this as a powerful lesson in, biological complexity just trumping our human need for control.
It does. We can measure 90% of the system, but that last 10% we can't measure. That internal hormonal signal of safety, that's the deciding factor.
So the 6 weeks of waiting, it wasn't wasted time. It was an essential biological incubation period.
Exactly. Time was necessary, but the 6-week mark, it just opened the door. It didn't guarantee success. Something else had to kick in for that one lucky pair.
And this is where it gets really interesting. Let's focus on the exact environment of that successful pair. The notes detail a setup that, frankly, flies in the face of what a lot of hobbyists try to do.
It was an exercise in extreme minimalism, functional minimalism. The notes say the pair was housed on the bottom rack of the setup.
Okay, why is that important?
Well, the bottom rack often gets less direct light, fewer rapid temperature swings, and maybe even more vibration from just people walking by in the room.
which could signal a more stable, dark, cave-like environment.
Potentially, yeah. And the tank design itself was stark.
Super stark. We are talking no artificial lighting meant to simulate day and night cycles, and, this is critical, no aquatic plants.
Zero distraction. Their only real structural element was the bare essentials.
Substrate, which Zebra Cichlids love to dig in.
And a singular terracotta pot. And that pot was the key piece of real estate, because that is exactly where the keeper later saw the fry wriggling. It offered immediate, non-negotiable shelter.
Okay, so after the mandatory 6 weeks of getting comfortable, the winning environment was simple, low, and sheltered. But the keeper identified one more variable, something only this pair had, that might have been the final trigger.
And it wasn't the substrate or the pot, it was the neighbors.
The neighbors.
Yeah. What's so fascinating is the social pressure. Unlike the pairs on the upper racks, this successful pair was only separated from the tanks next to them by glass. There were no opaque partitions,
So they could see their rivals, clearly.
which encouraged frequent visual competition,
Uh-huh.
a behavior we call flaring.
And this happened most during feeding times, which is, the most resource-intensive moment of the day.
Exactly. For anyone unfamiliar with the term, flaring is when a cichlid just extends its fins, its gills, it drops its jaw to look as big and threatening as possible. It's a constant, low-grade territorial defense.
And the theory in the notes is that this chronic, low-level stress and competition can actually stimulate breeding hormones.
That makes profound biological sense.
It does. If you suddenly see a rival next door, that's a direct threat to your territory, to your genes.
The biological response is to reproduce, now. You have to ensure your lineage survives before that perceived threat can take over.
So competition triggers the reproductive cycle as an act of survival. The stress of seeing a rival could be that final push that says, it's time, we have to defend this limited resource now.
Yes. But, and this is what we love to see in meticulous notes, the source material is quick to critically analyze this theory.
The keeper immediately pumps the brakes on the idea that flaring alone is the definitive trigger.
And this is where we have to separate correlation from causation. The author notes that they're skeptical because they had other pairs housed in mixed community tanks.
Right, and those community tanks would expose the fish to way more visual chaos and competition. You could argue it's much more stressful than just seeing one rival through the glass.
But those community tanks hadn't spawned yet.
So if the competition stress theory was the only trigger, the community tanks should have been spawning first. And they weren't.
It leaves us with a really subtle, specific combination of variables. It seems the flaring only worked in the context of, 1, the 6-week acclimation period being done,
And 2, that sheltered, minimalist setup that gave the pair a definitive territory to defend.
So it forces us to refine the question. Is the trigger just any stress, or is it localized, defined competition?
That's a great distinction.
The chaos of the community tank might be too overwhelming. It's too much stress to diffuse a threat, to encourage spawning. But seeing one clear rival from the safety of your own terracotta pot, that might be the perfect, focused, hormonal nudge.
It's like the difference between hearing general noise outside versus hearing someone actively knocking on your front door.
Precisely. One you can ignore. The other demands immediate action.
So once they navigated that whole environmental puzzle, the fry appeared. And that allowed for this really critical behavioral observation about parental duty.
Yeah, another species-specific insight.
The keeper had previous experience with polar-paired cichlids, right? Which set up this fascinating comparison.
It did. The observation was really distinct. With the polar parrot cichlids, there was a clear division of labor.
Okay, what did that look like?
The male would aggressively guard the exterior of the nest. He's the visible deterrent. Meanwhile, the female stays inside the structure to fan the brood, to tend to them. A classic division of labor.
But with the successful Zebra Cichlids, the dynamic was totally different.
Completely. The notes say the entire pair remained huddled together inside that terracotta pot, unified, tending to the brood.
It's a completely centralized, collaborative defense strategy.
What's so interesting there is the species-specific difference in, resource defense and parental roles. It's likely linked to their natural habitat.
But why would that unified defense be a better strategy in this specific environment?
Well, think about it. In a minimalist tank on a bottom rack, where that pot is the only real resource, a unified defense inside the pot might maximize the survival of the fry.
Okay, how so?
If one parent were outside guarding, they'd be exposed, maybe overwhelmed by a perceived threat. but the internal defense is more focused on hygiene and direct protection. Both parents fanning the brood inside that small pot ensures optimal oxygenation.
Ah, so this strategy isn't just behavioral, it's an optimization for that specific environment.
Exactly. But the keeper, ever the critical scientist, stresses caution.
As they should.
Yes, they note it's way too early to draw a definitive conclusion about the species' standard behavior from just one successful pair. This unified defense could be an anomaly.
Or maybe it's a learned response to that very minimalist tank they were in.
That's a real possibility, so that caution is vital. We've identified a unique pattern here, but confirming it requires more data points.
Right, but the observation gives us a clear baseline for comparison when, hopefully, the other 5 pairs eventually spawn.
And that transition from observation to action is what sets this material apart. The notes don't just stop when the fry are discovered, they immediately move into the management phase.
Let's talk about that. The practical next step. The keeper's focus had to shift from, how do I trigger spawning, to, how do I make sure these fries survive?
The notes show they kept monitoring the pair closely, but the primary adjustment was their feeding schedule. They immediately increased the quantity and specialized the diet.
Probably moving to something like newly hatched brine shrimp or special powders.
Something to support that rapid initial growth of the fry. This connects that biological success right back to direct, responsive management. You got the spawn, now you have to immediately optimize for survival.
So the data gathering translates into a concrete, immediate change in routine. It's the difference between just watching and, successful applied biology.
The successful spawn was the finish line of phase 1, but it was the starting gun for phase 2, rearing them.
So let's pull all these variables together for you, the listener. We started with a necessary 6-week acclimation period.
Then you have a specific, minimalist, low-light setup with just that one terracotta pot.
And finally, the possible behavioral trigger provided by that constant, localized visual competition, the flaring.
The success wasn't due to one silver bullet. It was the cumulative effect of these variables aligning, but only after that essential acclimatization was complete.
It's a powerful testament to the idea that sometimes less control over the measurable environment and more exposure to a specific biological stimulus can yield better results.
So what does this all mean for you, the learner? I mean, whether you keep fish or you optimize marketing campaigns.
It means success in complex systems, biological or otherwise. It often comes down to identifying these subtle, interconnected variables. It's not just one obvious factor.
You can control 90% of the operational environment, but your success might be hiding in that unmeasured, uncontrollable 10%.
The behavioral and the hormonal response.
It teaches us that biological systems, they kind of define their own version of a controlled environment. The keeper's control provided stability, but the fish's internal response to that localized stress that provided the impetus.
Absolutely. And that leaves us with our final provocative thought for you to consider as we wrap up this deep dive.
Despite the meticulous documentation of the physical environment, the water chemistry, the structure, the feeding routine, that precise primary trigger remains elusive.
We documented all the technical inputs. We know the pH, the temperature, the physical location. But if we connect this back to the bigger picture,
even when you are highly controlling the visible environment, is it possible that the subtle internal hormonal stress induced by competition, or that slow internal acclimatization to water parameters, the things we can't easily measure with a probe, are the real forces driving success?
we can measure the water, but we can't measure the fish's emotional response to seeing a rival during dinner.
Which leaves the question, can any environment truly be called controlled if the most vital factor for the outcome you want is invisible and ultimately uncontrollable?
Something to mull over until our next deep dive. We'll see you next time.